Eric, it's a sunny day here in Washington. How is it in New York?
Well, we could use some of your Washington sun here. We get an occasional sun peeking out over what is otherwise a hot, humid sky.
Ah, well, at least we're getting further into the winter and spring is on its way.
I sure hope it hurries.
Eric, my question for you today is you've developed a concept and a term called cosmic nodes. And
Yes.
yeah, and I want to hear more about that. What led you to feel that you needed to develop that term and that concept? Thank you.
Well, okay, that is a perfectly good question, and I hope I can give you a perfectly clear answer to it. First of all, we start at the very beginning. The paragon shift that we introduced was
Let me interrupt you. I think it's paradigm shift.
what did I say? Paradox?
I think you said paragon, which is also an interesting thing to explore.
Yeah, it is, but by paradigm is what I meant. So, the paradigm shift is that there is no basis for thinking that the cosmos becomes continuous at a certain cosmic scale. Everyone agrees that at the lowest cosmic scale, it is granular. Now, what can these granules possibly be? And now we come to a very interesting thing that was discovered not all that long ago, and that is over 2/3 of the entire mass energy of the cosmos in something that has been called dark matter, actually dark energy. Now, what the devil is the function of this dark energy? Well, it doesn't really have a function. It might the ideas thrown out is it might create the expansion of continuous space, but that doesn't make any sense. If there is no continuous space, what is the possible construction of space? Now, the construction of space is like asking, what is the Earth? The Earth is a periphery of a of a of a of a planet. When we talk about the Earth, we're really only talking the periphery of it. But the bulk of the Earth and the bulk of the mass energy of the Earth is not on the periphery, it is the interior of it. Now, the universe is the same. It is the expanding periphery of a four-dimensional hypersphere. Now, what is the interior of that hypersphere? It is not a smooth and continuous fabric. We have eliminated that. So what can it possibly be? And we get back to that 70% or more than 2/3 of the total mass energy of the Earth, which seems to have no function whatsoever. Now, the function of it clearly could be the structure of the interior of the cosmos. There are no other candidates for the job. And we're looking for something which is the dominant mass energy, and that is the only thing that is the dominant mass energy. So if this is indeed the case, then the next question is, what kind of a structure is it? Well, that takes us back to string theory, because string theory says that the universe must exist in a six-dimensional space because that is what is required to let all of the different particles express themselves by different modes of vibration. You need 6 dimensions for that. But see, these 6 dimensions are curled up. Now, in what form are they curled up? Well, a particle of energy is curled up. It is curled up in uh, the smallest size it can possibly be. It is 2 Planck lengths, twice the smallest thing on the Earth, where 1 Planck length is the smallest volume in which you can squeeze matter. This is 2 Planck lengths. It cannot be 1 Planck length, it is 2. Now, if this is indeed 2 Planck lengths, and we have independent verification that it is indeed that, then we consider it to be 6-dimensional particles, then we know exactly where these 6 dimensions come from. Every point in space has 6 dimensions. So consequently, space is 6-dimensional, which is what string theory requires it to be. And we have a structure of the cosmos that indeed we know what it is. It is particles that being called dark energy. And the adjective dark is simply another way of saying 6-dimensional, because you can't see anything that's 6-dimensional. It's dark. But 6-dimensional is the same thing we have postulated as dark. Now, why do I call it a node? Because if you see these 6-dimensional particles, they are actually interconnected by string filaments, very much like fiber optic cables are. Now, what does the internet consist of? It consists of computing points interconnected by the equivalent of very fine linear of fiber optic cables. So you have basically a structure that is very much like the structure that the internet is. And on the internet, we refer to the different computers as nodes of the internet. So this is the cosmic nodal network. And I've coined that term also. It's a cosmic, it's nodal, and it's a network. And it is basically very much an analogy to the internet. It is also a nodal network of computing capable points. Now, the computing capable point in the cosmos do very, very simple computing. They're not going to, solve problems like computers can, but they do, in fact, take care of creating energy gradients. They take care of propelling particles through the cosmos, and they serve certain functions of data transfer, of creating the conditions that explain gravity and so on. So we have a network very similarly in many ways to the internet, but it is made up of cosmic things, and we have called those cosmic things, or the cosmic points in the network as nodes. Very simply.
That's the cosmic node.
That's the cosmic nodal network.
That's great. Well, thanks. I think I may have another question in a minute, but
well, you're never run short of questions, Susan. I trust you to come up with another one in at least a minute.
All right. Well, let's stop here for now, and then we'll come back when we're ready for the next one. Thank you.
Okay.